All right, here we go. Back for another day. Um, oh, I don't know what I'm looking forward to, whether I'm looking forward to today or not. Yesterday, I did really well for the first part, but for the second part, got really stuck, bogged down with semantics, and just couldn't quite nail the algorithm that I needed to write to solve that second part. And well, if you saw yesterday's video, it was 50 minutes long. And about 30 of those minutes were me bumbling around trying to implement um, some smart way to complete yesterday's challenge. Um, and in the end, I kind of did a very naive algorithm, which still ran fast enough because these input sizes aren't that big. Uh, but yeah, that was just today. Today, let's hope for something that's going to run a little bit smoother. So 5 seconds to go. Let's um, let's see what happens. Here we go. Giant squid, day 4. I'm already 1.5 kilometers below the surface of the ocean, already so deep that I can't see any sunlight. Um, what you can see, however, is a giant squid that has attached itself to the outside of my submarine. Maybe it wants to play bingo? Bingo is played on a set of boards, each consisting of 5x5 grids and numbers. Numbers are chosen random, and the chosen number is marked on all boards on which it appears. Numbers might not appear on all boards. If all numbers in any row or any column of a board are marked, that board wins. Diagonals don't count. Okay, diagonals don't count. It's important. The submarine has a bingo subsystem, of course it does, to help passengers, currently me and the giant squid, pass the time. It automatically generates a random order in which to draw numbers and a random set of boards, which is my puzzle input, which looks like this. Okay, let's just take a quick look at what that looks like. I have a feeling, okay, so we're going to need to parse some boards. That's not too bad, but we're going to have to work on that. After the first 5 numbers are drawn, there are no winners, but the boards are marked as follows. After the next 6 numbers are drawn, there are still no winners. Finally, 24 is drawn. At this point, the third board wins because it has at least one complete row or column of marked numbers. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on that board. In this case, 188. So that's the third board. Then multiply that sum by the number that was just called when the board won, 24, to get the final score. To guarantee victory against the giant squid, figure out which board will be the first to win. What will be my final score if I chose that board? Okay, so we can get all the numbers in first. There's going to be a lot of new lines. So let's see what the data looks like. This. So the first line is going to be the first line is going to be numbers. So numbers is going to be the first line, and we're going to split them on commas, and we can probably leave them as strings, to be honest. I don't see it. Oh no, we do need to add them up eventually. Okay. So we're going to, I'll turn them into numbers. So for each number, in fact, we can just do this. Number, we'll append to numbers that number passed. So we're going to ignore any errors because we know it's all going to be fine. You know what? Let's not do that. String conv.a to y. Yes, that will give us numbers, and we just need to handle any errors. So let's check our numbers first. Cool, that seems fine. And then from here on out, we just need our boards. The easiest way to do this is probably to just collapse every 5 lines into a single line. So we can probably do something like, is there a strings.join? Yes. Elements and a separator. Cool. So I'm going to keep the boards as a one-dimensional array because it won't make any difference. So boards is going to be a string, like this, a board of, no, what am I doing? It's an array of numbers. Yeah. So we're going to say for I equals the second line, I less than the length of the array, the input, I plus plus, no, I plus equals, I'm just counting lines here. 1, 2, 3, 4, 5, 6, 6 lines. So we're going to take 2, 3, 4, 5, 6, 7. Yeah, so we're going to say, we're going to slice the data from I to I plus 5. So that gives us every 5 lines. We're going to string.join them with a space. Just because this way, and then we're going to split them again. It just makes it a bit easy. It's a one-liner this way. Not good programming practice, but I do that a lot. We're going to do this. We're going to have board is an array of ints. Board is this. So at this point, we're going to have a board. A board is an array of 25 numbers from top left to bottom right. And we're going to append that to the boards. And let's see what that looks like. That might fail, actually. Yeah, I was afraid of that. You see right there at the end, parsing empty string. If S is an empty string, because of the way I'm joining and splitting them, I think with the double spaces here, we end up with some empty elements in our array. So if S is empty string, we just ignore it and continue. Here we'll just do an extra check. If len of board is not 25, we'll also fatal here with the board, just to see what happens. But no, so every single one of our boards has exactly 25 numbers, which means I know that we parsed it properly. So now we have the list of all the numbers that come up and a list of all the boards. So how do we, what's the easiest way to do this? What we could do is we could zero out the numbers that are called, right? Because we only need to keep track of the last number and we don't need all the actually that's probably the easiest way to zero it out because we only need all the unmarked numbers right at the end, which means we can just sum the whole board actually, and it's a nice little trick. So for every number in numbers, which are the numbers that get called, we need to go over all the boards. For every board in boards, let's see, we'll just loop over them, I think. For I and, no, we do need indexes here, right? Yeah, we do need indexes. So for every index and value in this board, if v is n, then bi equals 0. And we break because we don't need to check anymore. The numbers should be unique on a board. I don't think it ever tells you that, but that's usually how bingo works, right? Yeah. I might have missed it in the description, but yeah. So we do that for the boards, and then here we need to check for win, which we'll write in a separate function, maybe? Maybe we won't. Checking for a win. How do you check for a win? There are 10 winning conditions. First is if any row. So yeah, you know what? We'll write in a separate function. Check win for a board. First, we want to check if the first row is all good. If it is, we win. So for I equals 0, I less than 5, I plus plus. If bi equals 0, if it's not 0. So win equals true. If it's not 0, win equals false. If win is still true at this point, so if win, return true. Otherwise, we check the next set of numbers from 5 and 10. Let's loop that. I don't trust myself anymore, not after yesterday's debacle. So I'm going to write it out like this. So from 10 to 15, and then from, you can clearly see this is loopable, but after yesterday, I'm a little bit PTSD from trying to optimize. So I'm just gonna do it like this. So that's the first set. And then the second set is similar. But what we do is, instead of I is less than 5, we go I is less than 25, and we plus equals 5. Whoops, no. 1. Almost did that wrong. And then 2. And then 3. And then 4. At the end, return false. So I know that's long, but it should be correct. Check when board. If check when board, we're going to format.println board. And we're going to print in as well, actually. Print in and the board. And we're going to return. So we have a board here. When the number 3 got called, which, let's see, number 3 is somewhere right there. So not many numbers have been called. We have 0 in the first column. No, we have all blank in the bottom column. So do I want to check any more? No, let's just try and get that in. What will be your final score if you choose that board? The first board to win? Yeah. So for I don't think I can use I. I've used I in here, this loop already. So for every number in this board, we just sum it up. We create that sum, and then we print line sum times n, I think was the number that made us win. That feels reasonable. Okay, I got it. Let's go to part 2. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards a giant squid could play at once. So rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. In the above example, the second board is the last to win, which happens after 13 is eventually called and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of this. Find out which board would win last. So we just need a way to keep track of which boards win last, right? I think we can do that if we just change this loop a little bit. What we'll do is we're going to so we're going to loop with the with an index instead, like this. Now, if it wins, we print we'll print out the information about the board. Why not? Then instead of returning, we're going to break board win is false. We're going to say board win is true. And then outside this loop, this doesn't work. We're going to loop backwards through the boards. We're going to loop backwards through the board. And then if a board wins, we're going to delete it from the array of boards. So when we're left with one board and the final one, then we know which board was the last board to win. Or you know what? We don't even have to do this. Let's keep it nice and simple and just do this. What we do is we track how many boards we have. Board win, yeah, this makes a lot more sense. Is we're going to make an array of bulls, which is as long as the number of boards we have. And they're going to all start off as false. If check win B, we don't have, every B needs to be boards B. If check win boards B, range boards B, and we're going to print out here boards B. If the board has 1, we're going to skip it. So if the board has 1, we say board win B is true. And here we say if board win B, we skip it. So basically the last board to print, it's just going to print all my boards. It should print one board at a time and print them all out. So that is the first board to win, and right at the end, at 21 is the last board to win, and that score is 6594. I'm happy with that. Let's go, 400th. Okay, after yesterday's debacle, we have kind of managed to pull ourselves back and gotten this at 400, which is quite a decent rank. So I'm quite happy with that. It was actually quite a nice puzzle with this kind of 2D array sort of thing. One of the main things I did was, of course, to not handle the board as a 2D array, and I just did everything as a one-dimensional array. Which, if you really think about it, a 2D array in memory is going to be 1D anyway. Sorry, a 2D array in memory is going to be laid out 1D anyway. So it would have just made my loops a little bit more complicated by doing that. It did mean for the checking the win, I wrote it out by hand, the entire thing. I could totally have written that out as a loop, it would have just been a little bit risky, and I wasn't quite feeling up to it. But you can kind of see how the loop would work, right, with that. It is one of those slightly more, well, I was going to say it was something in JavaScript, for example. You could slice the array and then just go dot what is it, dot all equals 0, right? In JavaScript, you could have probably done something like board, so b dot slice 0, 5 dot all equals 0. Instead of this, again, that's the trade-off you have for writing in Go. Instead of these higher order functions, you just have to write for loops, which you can kind of hide away in a function like this, but it's a trade-off. You wouldn't quite have been able to do that with this column anyway. So with the columns, because I know that these boards are 5 by 5, right? The first top left item is 0. The first item in the second line is 0 plus 5, because that's how you loop around, and so on. So the second half of the loop is a little bit different, but yeah. And the principle here of just writing out the entire bit of code, this is actually a TDD principle, right? In TDD, like I didn't go the whole way, right? But in TDD, it's the test, what is it? Test, write, refactor? Test, something like test, write your code, write your test, write your code, and then refactor. So I stopped at the write your code bit because I'm going for speed. But clearly, if you were doing this for real, you would want to refactor this check when function into something that's a little bit nicer. Besides that, yeah, I realized I went a little bit fast. The parsing bit, it's just parsing. There's not much to talk about it. And yeah, and then once you've done that, it's literally just going through each board and then marking off each number as you go. I think setting the numbers to 0 was a nice way to do it. You have to basically go through, loop through the entire board to match each number every time anyway, because the boards can't be sorted unless you're building a nicer data structure of some kind. But if you wanted to keep it simple, like I did, and just have an array, then I think setting to 0 was nice, because it meant down here, once we've got the win, then I just had to sum up the entire array. And I didn't have to like go through and figure out which numbers were marked and which ones weren't, because they were all set to 0, and it worked. So really cool puzzle today. I liked it. I enjoyed it. I think it's given me a little bit of confidence back after yesterday. So looking forward to the rest, and I hope to see you again tomorrow.